Okay, so on 15 through 20, you're asked to find various powers of I. Now, it says using long division and the pattern of the powers of I determine the value of each of the following. So, in order to use the pattern, you actually have to know the pattern. So, let's just talk for a second. If I have I to the 0 power, now, if you think about like 2 squared, 2 cubed, 2 to the first, and 2 to the 0. So 2 to the first is 2, 2 squared is 4, and 2 cubed is 8. Um, so it looks like going this way, I'm multiplying by 2 every time. I multiply by 1 more 2, 1 more 2, 1 more 2. So that means going this way, I'm dividing by 2. And when you divide 2 by 2, you get 1. Anything to the 0 power except for 0 is 1. Okay? So I to the 0 is 1. Now, I itself, if you raise it to the first power, if you raise something to the first power, I mean, you haven't done anything to it. It's just that number. Okay? I squared. Now, we worked with I quite a bit, and we should know that I is the square root of negative 1. We're going to go in terms of i's. I squared is negative 1, or I is negative 1. I is the square root of negative 1. So I squared is the square root of negative 1 squared, which is just negative 1. So I squared is negative 1. Now, I cubed is I times I times I. Or you can think of it as I squared times another I. We already know that I squared is negative 1, so that's just negative I. Or you can just remember the pattern. If you know anything with 0 is 1, you know that's I, you know that's negative 1. Well, there's only one other option without it being one of the same, negative I. So you only have 4 options, 1, negative 1, I, and negative I. Okay? Now, if I were to find I to the 4th, so if I were to multiply I cubed times another I. So I cubed is I times I times I times I, or, sorry, I to the 4th. So I to the 4th is I cubed times another I, or I squared times I squared, which might be easier. I squared times I squared. But let's just go ahead and do this. I cubed is negative I times another I is a negative I squared, but I squared is negative 1, which means that's just a positive 1. It starts the pattern over. If you multiply another one by I, you get I. And if you multiply another I, you get I squared, which is negative 1. So it just keeps on going with the same pattern. Now, what you're supposed to notice is that it's a pattern of 4, right? If I were to divide 4 into 7, I see that 4 goes into 7 one time. 1 times 4 is 4. Subtract, and I get a remainder of 3. So you might notice that I to the 7th is the same thing as I cubed, right? And the remainder is the same thing as that. If I were to think of, so that's 7, I to the 8th, I to the 9th, I to the 10th. So if I were to think, how many times does 4 go into 10? 4 doesn't go into 1, 4 goes into 10 2 times. 4 times 2 is 8. Subtract, and I get 2. So 4 goes into 10 twice with a remainder of 2. And I to the 10th is the same thing as I squared, which is negative 1. So when you know this pattern, what I would expect you to memorize is this right here. 1I, negative 1, negative I. Note that you have to divide by 4, and whatever the remainder is, if it's a remainder of 1, then it's the same thing as I to the first, which is I. If it's a remainder of 3, it's the same thing as I cubed, which is negative I. Okay? So let's go ahead and start dividing. I need to know what I to the 2050 is. So I'm going to go ahead and use this space like this to do the division. And it's however you want to do it. I'm just going to go ahead and use it. Okay. So this is going to be number 15. I want to know how many times does 4 go into 2050. So 4 does not go into 2, but 4 does go into 20. 4 goes into 20 5 times, so 4 times 5 is 20. Subtract, and I've got 0. Okay? Bring down the 5. How many times does 4 go into 5? 4 goes into 5 one time, so I multiply 4 times 1 and I get 4. Subtract, and I get 1. Bring down the 0. Okay, 4 goes into 10 2 times, and 4 times 2 is 8. I guess I could use a different color. 8. Subtract, and I'm left with 2. So that means I to the 2050 equals I, whatever the remainder is, squared. And I know that I squared is negative 1. So this right here is negative 1. Now, for those of you that type it in the calculator, if you want to check your work, or if you're allowed a calculator on the test, then you can go second, I. So I is above, sorry, I just kind of jumped over that. I is above the decimal. So if you go second and then the decimal, you get I. Raise to the, so if you want to raise something, use the caret key right here. I don't know why it's called a caret. 2050, I type it in and I get this number right here. -1 plus 4.5 e negative 11 I. So let me write that down real quick. I'll write it right here. That's fine. -1 plus 4.5 e negative 11 I. Okay, so what that means to me is -1. Now this right here is 4.5 times 10 to the negative 11. So if I want to know what that looks like, then I would take the decimal and move it 11 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then between that, I have a ton of zeros. So if I told you that I was giving you money, and the amount of money I was giving you is 0.0000000000045, I'm not giving you anything. Okay, I don't even know what that is. I don't even know what that would be in terms of money. But I know it's really tiny, and so here's what the calculator is doing is, I guess what it's doing is some kind of approximation. And so it gets really close to the actual answer, and the actual answer for that is -1 plus 0 I. And if you have 0 I, then there's no imaginary term. It's just -1. Okay? Which is what we got when we divided. Oh. Okay. So I'm going to do the next one. I'll go ahead and go down right here. Well, I guess I could go in order. No, I don't need to do that. Okay. So I'm going to divide 4 into 675. So I see that 4 goes into 6 one time. 4 times 6 is 4. Subtract, and I'm left with 2. Okay. Bring down the 7. 4 goes into 27. Well, 4 times 8 is, or 4 times 7 is 28, so 4 times 6 is 24. So 6, 4 times 6 is 24. Subtract, and I'm left with 3. Bring down the 5. 4 goes into 35. Well, 4 times 9 is 36, so 4 times 8 is 32. Subtract, and I'm left with 3. So here's what I know. I know the I to the 675th is the same thing as I to the remainder is 3, so I cubed. And I know from my pattern that I cubed is negative I. So don't forget. It's got a remainder of 3. Then it's like I cubed, which is negative I. Okay? Let's do 17. I want to divide 4 into, oh, well, I guess I could go ahead and type that in real quick, just so you can see. Second I raised to the 675th, and I get 4.25 e to the negative 11th minus I. So 4.25 e negative 11 minus I. Okay, that right there, that number, that whole number is 0, and 0 minus I is just negative I. Okay? On 17, I want to divide 4 into 1276. Okay. 4 does not go into 1. So I have to think. I have to think 4 goes into 12 how many times, and that is 3. 4 times 3 is 12. Subtract, and I'm left with 0. So now I bring down the 7. 4 goes into 7 one time, and that is 4 times 1 is 4. Subtract, and I'm left with 3. Bring down the 6. And 4 goes into 36 9 times, and that is evenly, which means there's a remainder of 0. So that means I to the 1276, 1276, equals I to the 0. And we know the I to the 0 is 1. Okay? And if you type that in, you would get I raised raised to the 1,276. 1 plus all of this times I, and remember that this number right there is 0, so I've got 1 plus 0I, which is just 1. Okay. Let's do number 18. So I need to divide 4 into 6,027. Okay, 4 goes into 6 one time. 4 times 1 is 4. Subtract, and I'm left with 2. And I need to bring down a 0. Okay, 4 goes into 25 times, and that is 20 with a remainder of 0. Bring down the 2. Now, 4 does not go into 2, so I have to put a 0 there. Go ahead and multiply. 4 times 0 is 0. Subtract, bring down the 2 again. Or it simplifies down to 2. And then I bring down the 7. Okay, 4 goes into 27. I feel like I already did this. Oh, yeah, I did. Right here. But anyway, 6. 4 times 6 is 24. And so then I simplify and I get 30. Okay, so I get that. Interesting. I to the 6,027 is equivalent to I cubed, because the remainder is 3, which means my answer is negative I. Okay, I'm going to check it right quick. I raised to the 6,027, and that is 3.77e to the negative 11th. 0 minus I, and 0 minus I is negative I. Okay, let's do number 19. So 19, 4 divided into 2, 5, 6, 3, 4, 1. 4 goes into, 4 does not go into 2, but 4 goes into 25 6 times. 4 times 6 is 24. Subtract and bring down the, well, anyway, subtract and get 1. Bring down, you cannot see that one. Bring down the 6. 4 times, 4 goes into 16 4 times evenly, so I get 16 and I get 0. Bring down the 3. 4 does not go into 3 at all, so I had to put a 0 above it. 4 times 0 is 0. Subtract, and I've got the 3 still. But now I bring down the 4. 4 goes into 34. Well, 4 times 8 is 32, so I'm going to think 8. 4 times 8 is 32. Subtract, and we're left with 2. And then bring down the 1. 4 goes into 21 5 times, because 4 times 5 is 20. Subtract, and I'm left with 1. Okay, so that means I to the 256,341 equals I to the first, which is just I. And if I were to type that in, I raised to the 256,341, I get 1.4609 e to the negative 9th, which is 0 plus I, and 0 plus I is I. So last one of this type, I've got I to the 37,428. So let me divide that. 4 goes into 37428. 4 does not go into 3, so 4 goes into 37 9 times, because 4 times 9 is 36. Subtraction, I've got 1. Bring down the 4. 4 times 3 is 12, so I subtract and I get 2. Bring down the 2. 4 goes into 22 5 times, because 4 times 5 is 20. Get a 2. Bring down the 8. 4 goes into 28 7 times evenly, and so I get a remainder of 0. So then I to this equals I to the 0, and I to the 0 is 1. Okay, So anytime I have to the 0, or anything to, to the 0 power is 1. So let me go ahead and check that. I've got I raised to the 37428, and I get 1 plus 4.828 e negative 10. So 1 plus 0 I, and 1 plus 0 I is just 1. Okay, so that is that for the powers of I.